In the horizontal projectile lab, a projectile shot versus dropped versus code simulation. The purpose is to test the accuracy of the code model, which models a falling object, not accounting for friction. The variables being compared are the displacement of a projectile along the x-axis or horizontal, and the hang time of a projectile, a falling projectile. The significance of this experiment is comparing the real or experimental values, which is like what happens in real life, compared to the theoretical values, which is what the code gives. The theoretical value turned out to be very similar to the code. Very similar to the code. The percent error was under 10%. If friction had been accounted for, the percent error margin would have been much smaller. Important concepts. Perpendicular forces do not interact or affect each other. So that means that an object's vertical velocity does not affect its horizontal velocity and vice versa. Another important concept is that things dropped from the same height fall at the same speed regardless of their horizontal velocity. If they have different horizontal velocities, one might end up further than the other when they hit the ground. Math equations used. The percent error equation, which is the theoretical value minus the experimental value divided by the theoretical value. The momentum equation, which is momentum equals mass times velocity. And slope, which is the change in x over the change in time, and the average, which is the total value of everything divided by how many things you have. The setup. There were 6 separate trials taken, 3 of which were when the ball was dropped from various heights in a table or stool, and 3 were taken when the ball was launched off the table or stools at various heights. Stools, tennis ball, spring, a meter stick, and a camera. And you need a meter stick to set a scale for your video. That in the camera, and that's all you need for this experiment. The results. So the code was fairly accurate when predicting predicting how long a falling projectile would actually be in the air, with an overall percent error of 4.4%. The code was not so accurate, however, at predicting the final x displacement of a falling object, with an average percent error of 19.4. Overall, the average percent error was 8.4 throughout the entire experiment. Sources of error. Systematic sources of error. Friction in the air. Friction in the air was always in the experiment, so therefore it was a systematic error, and it impacted our results. Different initial velocities, whether the spring was pulled back or hit the ball at different speeds, it could have affected the x displacement of the tennis ball. Logger Pro tracking errors. It's hard to track the tennis ball when the ball is traveling and the center of mass is not always correctly measured. Random errors. Spinning of the ball could have affected the final X displacement of the ball. In the spring, if it wasn't consistent every time, it could have also affected the X displacement. Improvements. Do more or test more heights and more data points to make the data more accurate, to lessen the gap in the percent error between the code and what happened in real life.